Okay, today's our last day of learning new stuff for this chapter. Good news is that tomorrow we'll have another day to review it all before you take a quiz on Wednesday. So here we go. Today we're going to talk about writing hyperbola equations. Just like in ellipses, there's three basic things that we need to write a hyperbola equations. We need the center, and we need delta x and delta y. Remember in a hyperbola that c squared is a squared plus b squared. And the big thing for a hyperbola that's different than an ellipse is that we have to decide which way the parabola opens to determine which variable should be listed first. We can't start the equation until we know that information. Okay, so just like before, I'm going to recommend that you start with a little sketch. Again, it doesn't have to be perfect. You're just going to see some different information from your sketch. So this time I've got vertices at negative 2, 2 and at negative 2, 4. And just from that, I can now decide that this hyperbola is going to open up and down, which means that y is going to come first. I can also find the center. Since it's right in between the two, it has to be at negative 2, 3. And I know that delta y, my y distance, is just 1. So if I'm going to start my equation, I know that y has to come first. So I've got y minus 3 squared minus x plus 2 squared. And remember that hyperbola equations, just like ellipses, always equal 1. And then underneath y, I can go ahead and plug in 1 squared is 1. What I have left to find is my delta x. So here's where I'm going to use my asymptotes. Now, if you were having a heads up, you probably could have found your center by looking at your asymptotes as well. Make sure that they match. We've got y minus 3, x plus 2, and x plus 2. And now here's where the slope comes into play. The slope is delta y over delta x, and that is 1 over 2. Well, we already knew that delta y was 1, so that means that delta x now has to be 2. So underneath x, I'm going to plug in the number 4. Okay, the next type is if I give you vertices and a point on the hyperbola. Again, I'm going to start with a little sketch. So vertices at 0, 6 and 0, negative 6. And just from that, I can now figure out that my center has to be at 0, 0. I can also figure out that this is another hyperbola that opens up and down, so y has to come first. And I know that delta y is 6. So again, if I'm going to start my equation, I've got y squared over something minus x squared over something equals 1. And underneath y, I can plug in the number 36. Now, with the point on the hyperbola, what I'm going to do is I'm going to plug in everything that I know, and then I'm going to plug in the point for x and y. So it's going to look something like this. Y squared is 18 now, so 18 squared over 36 minus x is 4 root 2 squared over b squared, because remember in a hyperbola a always comes first. If I simplify, 18 squared is 324. 4 root 2 squared is 16 times 2, so 32 over b squared. I'll subtract 324 over 36 is actually 9. And then I'll go ahead and subtract that over. So it looks like I've got negative 32 over b squared equals negative 8. I'll times by the b squared and divide by negative 8. So now I've got b squared is 4, and that's really what I need for my equation, so I can just plug that in underneath x. Okay, the next problem is interesting too, because instead of giving you both vertices, I'm giving you one vertex happening at 9, negative 13. I'm giving you the focus happening at 9, negative 17, and the center happening at 9, negative 7. So just from this information, again, I'm going to know, because the focus is on the inside, that this is a hyperbola that opens up and down, which means y comes first. And since I know the center, I can plug in that much. So I've got, section this off here. So I've got x, oh, but y comes first. Let me fix that. So I've got y plus 7 squared minus x minus 9 squared equals 1. And the other information that I know is that delta y from negative 7 to negative 13 is a distance of 6. So underneath y, I can plug in 36. This time I also need to figure out the distance from the center to the focus from negative 7 to negative 17. That's going to be c, and in this problem that's 10. So then I'm going to do c squared is a squared plus b squared. 10 squared is, since delta y is first, that's a, so 36 plus b squared. 100 minus 36 leaves me with 64 for b squared. So underneath x, I'm going to plug in 64. So you can see it's really important to keep doing the sketches, just like we've been doing for all the other problems, because you can really learn a lot just from looking at your picture. Okay, for the next one I've given you the center at 8, 7. And then I've given you the vertex at 11, 7. So center's here, vertex is out here. That tells me that this hyperbola has to open right and left. So this time x is going to come first. I already have the center, so I can start my equation. Just by plugging that in, I've got x minus 8 squared over something plus y minus 7 squared over something equals 1. And I already know that my x distance from 8 to 11 is a distance of 3. So underneath x, I'm going to plug in 9. This time, the extra information was the eccentricity is 5 over 3. Remember that eccentricity is c over a. I already know that delta x being 3 is a because it has to come first. Since it opens right and left, whatever's underneath the first part is a. So if a is 3 and the eccentricity is supposed to be 5 over 3, c must equal 5. So now remember that c is not what goes underneath y. The equation is c squared is a squared plus b squared. So now I know c, which is good, so I can say c squared is 25 is 9 plus b squared, but I still have to solve to figure out that b squared is 16. That's what goes underneath y. Don't think, oh, I did all this work, I'm done, and just plug c underneath y. You still have to solve for b squared. Okay, for this one I've given you foci at negative 2, 9 and negative 2, negative 1, and then eccentricity. So the fact that the two foci are here does still tell me enough information to know that these are hyperbolas that are going to open up and down. And I can also find the center. Remember, the center is directly between the foci. So if the total distance between the foci is 10, halfway between is going to be 5, and that's going to put my center at negative 2, 4. Since I know it opens up and down, I know y comes first. And if I plug in the center, I've got y minus 4 squared over something minus x plus 2 squared over something equals 1. Now, eccentricity is c over a. Also, from looking at my picture, I know that c, the distance between the center and the focus, is 5. So if eccentricity is c over a, and that's supposed to be 5 over 4, now I know that a is 4. So underneath y, because a always comes first in a hyperbola, I can plug in 4 squared, which is 16. And then I can do solving for b squared. 25 equals 16 plus b squared, so b squared must be 9. Okay, similar problem for number 6, where I've just given you the foci, 3 root 5 and negative 3 root 5. Doesn't really matter what those decimals are because I can get all the information I need from that. I know that the center has to then be at 0, 0. And I know that C, the distance from the center to the focus, is 3 root 5. I also know that this is a hyperbola that's going to open right and left because we have to hug these foci. So if it opens right and left, then that means x comes first. So I can start my equation x squared over something minus y squared over something equals 1. This time I've given you the asymptotes. The key when I give you the asymptotes is the slope. Remember that slope is delta y over delta x, which in this case, because y comes second, is going to be b over a. So b over a is 2 over 1. I could cross multiply here and say 2a equals b. Now what I'm going to have to do here is combine this knowledge with using my focus. The c squared is a squared plus b squared. So I've got 3 root 5 squared is a squared plus b squared. Now I'm going to actually plug in 2a for b so that I have a little bit of a system happening here. 3 root 5 squared is 9 times 5, 45, equals a squared plus 2a squared. So 45 is a squared plus 4a squared because you square the 2 and the a. I've got 5a squared equals 45, divide by 5, so a squared is actually 9. So underneath x, I'm going to plug in 9. Then to get b, I could finish solving this one and say that a is plus or minus 3. So b is 2 times 3, which is 6, and then underneath y, I would square that and plug in 36. That's about as tricky as I'm going to make it for you, but it is something that you should know how to do. Okay, these last two I'm giving you are just back to vertices and foci, but the numbers that I'm giving you are a little bit as not nice to work with as the beginning ones. So here we go, we've got vertices at 2, 0, and negative 2, 0. So from that, I know that I have a center at 0, 0, and I know that delta x is going to be 2, and I know that this hyperbola is going to open right and left, which means that x has to come first. So far I have an equation that says x squared over something minus y squared over something equals 1, and underneath x I can plug in 2 squared, which is 4. Here's where my foci come into play. 2 root 2 is a little bit more than 2, and that tells me that c, the distance from the center to the focus, is 2 root 2. So now I'm going to plug it in 2 root 2 squared equals a squared, which I can just already write as 4, plus b squared. 2 root 2 squared is 4 times 2, which is 8. So I'm getting that b squared is also 4. That gets plugged in underneath y. So same procedure as what we did earlier, it's just that you have a little bit uglier numbers with those 2 root 2's. Okay, one more. We've got vertices at negative 3, negative 3, and at 1, negative 3. So again, just from that, I can figure out that my center, the total distance between those is 4, so it's just 2 away. So it's going to be at negative 1, negative 3. I know that delta x is 2, and I know that this hyperbola is going to open right and left, so that means that x comes first. So I plug in my center, I've got x plus 1 squared over something minus y plus 3 squared over something equals 1, and underneath x I'm going to plug in 4. Now I'm just going to do that same thing. My foci are at negative 1 plus or minus root 13 comma negative 3. So again, you probably could have looked here to be able to find your center, negative 1, negative 3. That also makes it a little bit easier to find c, the distance from the center to the foci, being root 13. So then I plug it in, c squared is a squared plus b squared, root 13 squared is 13, subtract the 4, and you're going to get that b squared is 9. So underneath y I plug in 9, and then I'm done. So pretty much the same thing as what we did for ellipses, being find the center, find the x distance, find the y distance, and plug it in. Just some different possibilities of things I can give you. If you guys do have questions, we will go over it tomorrow, and then again, your quiz is on Wednesday. Good luck.